So put your hand up if you've tried learning a new language. Quite a lot of you. So the way that languages are taught in schools, in phrase books, is an approach called push learning, where there are certain topics that you're taught in a very structured way, maybe how to order a coffee, how to say where you're from, how to talk about the weather. But there's another approach to learning called pull learning, where you learn the things that you want to learn. So here I am. I just arrived in Dublin airport yesterday. Maybe I want to learn how to say something in the local language. I want to learn how to say something in Irish. Wouldn't it be really cool if I could just look at this scene and say, this is a mala duff, a black backpack, or this is a guy wearing a red shirt. Maybe someone can help me pronounce that in Irish. Anyone volunteer? I'll have a go. Fair de lane de. But you get the point. Wouldn't it be cool if I could look at this scene and have it described to me in the language that I am trying to learn? I'm here to tell you that this is possible, and deep learning is what makes this possible. So deep learning is an approach to machine learning which uses biologically inspired artificial neural networks, which are a cascade of multiple layers of nonlinear processing units. And implementing deep learning involves two phases, training and inference. The training phase, this model, so for example, this is a model with 2 hidden layers. This model is shown a large set of observational data. And from this data, the model learns how to extract latent insights and recognize patterns. The second step is called inference, where the model is shown a completely new image or a piece of text, so completely unseen data, and it can use what it's learnt from the observations in order to make predictions on something it's never seen before. I want to talk to you today about implementing machine learning, not machine learning theory, but actually implementing. And to start with, I want to focus on how machine learning systems are currently implemented on the server, some of the challenges associated with this approach, and then I want to introduce a completely new approach of client-side machine learning. I have a great demo to show you of a client-side machine learning application, and I'm going to talk you through the code, the architecture, and then I'm going to end by giving you a decision framework for figuring out if you want to implement machine learning, should you put it on the client or should you put it on the server? So before I start, I'm Nikhila Ravi. I am a software engineer at Facebook in San Francisco. And for the past year, I've spent at Harvard. I was studying machine learning and AI. And before that, I learned how to code at Founders and Coders 2 years ago. So alongside this, I also co-direct a nonprofit called OpenEd.ai, focusing on AI for education applications and building this in an open source way. And a quick shout out to my co-director at OpenEd, Anshul Bagi. We worked together on putting this talk and demo together. So jumping right in. Machine learning traditionally is done mostly on the server. So the 2 phases I talked about, training and inference, they're both done on the server. And the client just sends data, which the model then processes on the server and sends the output back to the client. There's a couple of issues associated with this approach, and I'm going to focus on 3 key challenges. The first is the infrastructure costs. So over the summer, I was working on a couple of machine learning projects, and I was using an AWS EC2 instance to run a GPU instance to train a model. So I think many of you must have used AWS before, but it was costing $24 per day to run a GPU instance. And this could be quite prohibitive for many people. For me as a student, maybe for other people working in small companies. And so this is a big challenge. The second is around network connectivity and delay. So if your application depends on having strong network connection, or maybe it operates in an environment in which there might be high latency, having the model running on the server could cause significant problems. And the third problem I want to focus on is the technical expertise that you need in order to actually set up a machine learning system on the server. But there is some good news. And the good news is that end-user devices, like phones and laptops and browsers, are becoming increasingly more powerful. So the decrease in cost and the increase in prevalence of GPUs on laptops, coupled with the introduction of modern web APIs that expose low-level technology, so like WebAssembly, WebGPU, WebGL, this enables hardware-accelerated graphics and computation. And this is really enabling the browser to become a very powerful computational engine. And this is great news for processor-intensive applications like machine learning. Similarly, on the phone, increased power on phones and low-level APIs have enabled machine learning to be actually run on the device itself. So this is opening up the possibility for a whole new approach to machine learning that's done on the client. So training, so the two phases I talked about before, training and inference, training is still done on the server, but actually running of the model on inference can actually be done in the browser. So I want to talk to you and show you an example of how client-side machine learning can work. And to do that, I have an example, which is image captioning. So given an image, like this one, I want to be able to generate a natural language description of what's happening in that image. So here there's a man jumping into a lake, into a lagoon. And the description is generated using a machine learning model. So there's a couple of steps involved in actually getting this to work. So there's two models that are involved. The first is an image model. So an image is passed through the image model to generate a feature vector. And a feature vector is just a fixed dimensional representation of that image. The feature vector is then passed through the second model, which is a text model. And so this is trained on a large corpus of English language. And this model is used to actually generate the caption. So the image passes through two models, and out we get a caption describing that image. So now I'm going to give you a demo of an application that I've built, which is called LingoLens. And it's a Chrome extension which does exactly what I've just said. So it generates a caption for an image on a web page. So I'm going to make this bigger. So this is my Instagram page. I'm just going to refresh. This is my Instagram page. So you can see that as soon as I refreshed, these little buttons popped up. Analyze. So I'm going to scroll down. OK, this is when I had sushi a couple of weeks ago. I'm going to click Analyze. And what's happening is the image is being fed through this image captioning model, which is running in the browser. It's generating a natural language sentence description for that image and translating it into a different language. So in this case, it's translating it into Spanish. So if I hover over this, it says a close-up of a plate of food. It's a fairly accurate description. OK, let's try another one. So this is the Bay Bridge. So I moved to San Francisco 2 months ago, was walking by the Bay Bridge, took a picture. So you can see that, again, it's captioning. So it's taking the image, passing it through the model, generating a natural language description, and then now it's translating it into Spanish again. And what does it say? It says, a bridge spanning the width of a river. So this entire application is running in the browser. And I'm going to show you, I'm going to prove to you that this is what's happening. So this, as I mentioned, this is a Chrome extension. Chrome extension has you can inspect what's happening in the browser, and you can see that here there's a WebAssembly kernel that's loaded, which is running the model. I just want you to remember this, because I'm going to talk about the architecture and the code and show you what's actually happening. But this entire application is running in the browser. And if anyone wants to volunteer their Instagram page, we can try it on something that's completely new. Anyone want to volunteer? Yeah?
Sites
PSY? KZZ. Okay, let's try. Oh, it's private. Anyone here? Anyone with a public? Pardon, say that again? MBEG? MPEG, okay. All right, let's hope this is public. So we're just going to wait for the button to load. Maybe I'll try this one. Try this one. We'll see how it works. So it's captioning, taking the image, generating a sentence, and then translating it to Spanish again. Okay, what does it say? It says, a man sitting on a bench in a park. Close enough, close enough. Maybe you can try another one. Maybe you can try this one. Let's see if it picks out that there's two people in the photo. So this is taking the image, generating the caption, and I'm going to talk you through the actual architecture of how this works next. So it says, a man sitting on a bench reading a book. Okay, interesting. Okay. Thank you for volunteering. All right. Okay. So now you've seen it work, you're probably wondering, how does it work? So behind the scenes, this application uses something called WebDNN, so Web Deep Neural Networks. And this library offers two components. The first is a Python API, which takes a model defined in Python, converts it into a format which can run in the browser. And the second is a JavaScript API, which actually takes this model, converts it into a web-compatible format, and then runs it in the browser. So end-to-end, this is the architecture for the application, starting with the Python model on this side, and then the browser on the far side. I'm going to take you step by step through how this works. I see some of you taking photos. I'll make the slides available afterwards. So, okay. So the first step is to take a model that's defined in Python. So this can use any of the Python frameworks for neural networks, for example, Chainer, Keras, etc. So you take the model, take the weights. So the weights are what are available after the model has been trained. So take the model and the weights, pass them through this graph transpiler, and output a JSON file which has the graph as a format that can be loaded into the browser. And this uses the graph transpiler Python API. So there's only one slide with Python, and this is the only step that you need to do in Python. And here you can see that WebDNN has two functions, a Keras converter and a generate descriptor. And both of these are used to load a model in Python and then output a graph descriptor and optimize weights. So the second step is to load the model into the browser and actually run inference. And by that I mean passing in an image and outputting a caption. So this step uses the JavaScript API of WebDNN. It takes in the model defined in a JSON file along with the optimized weights. It loads the model into memory in the browser, and it uses one of several web APIs. So it could use WebAssembly, WebGL, WebGPU. Currently, WebGPU is only supported in Safari Technology Preview, but WebAssembly is supported in Chrome. So after the model's been loaded into browser, it can then be run. So images can be passed into it, and then captions can be generated. So how does this work? What code do you need to make it work? So loading WebDNN is as simple as including the WebDNN.js script along with another script called inflate, which is used to load the model. And the runModels.js file contains the code to actually call the model. And I'm going to take you through a couple of the functions in this script. So the first step is actually loading the model. And the first two sections of this function load model 1 and model 2. So if you remember, model 1 takes an image and generates a feature vector. Model 2 takes this feature vector and generates a caption. So load the two models, so load the two files. And then the last step which is instantiating a class called image caption generator to encapsulate these two models and make it easier to call. The second step is running inference, so actually passing an image through the model and generating a caption. So here you can see the two steps I mentioned. First is image feature, so running the image through model 1. The second step is taking the feature vector, passing it through model 2, and generating the sentence. So the last step is actually encapsulating this into a Chrome extension. So the first two steps I talked about, transpiling the model and loading and running in the browser, are applicable to any client-side machine learning application. But the demo I gave you takes it one step further and puts it into a Chrome extension. There's a couple of interesting architecture points that I want to share with you about Chrome extensions. So the way the Chrome extension works, there's two parts. There's a background script and a content script. The background script runs continuously in the browser. This is where the model is loaded, and this is where the machine learning model runs. The content script is injected into each page, each tab that's loaded in the browser. So the little analyze buttons that you saw, they're put in by the content script. So the content script takes the images from the web page. It sends them to the background script, which then runs them through the model, and the model sends the output sentences back to the content script. So that's the architecture of how the Chrome extension works. And Chrome has an interesting message passing API, which makes this really easy to do. So here are a couple of code snippets that show how this works. So here, this is the content script. The left-hand side is the content script, and the far side is the background script. So the content script takes the image from the web page, sends a message to the background script. The background script has a listener for that message. It then takes the image and calls this function run with the image and the tab ID that called the background script. The image is then passed through the model, so it calls the load models and run inference functions. Once we have an output caption, we can then send it back to the content script along with the tab ID, so it knows which tab to send it back to. And the content script has another listener, which can then take the caption, and then you can do whatever you want with it on the browser, on the front end. So that's just a quick demo of an example of client-side machine learning. But there is so much more that you can do with client-side ML. A couple of other examples are things like image classification. So given an image, is it a cat or a dog? Can you tell what's actually in the image? You could also do things like style transfer. Some of you may have seen an app called Prisma, which takes, for example, a Van Gogh painting and a normal image and applies a Van Gogh style to a normal image. You can do other things like sentiment classification, where you can see whether a sentence has positive or negative mood. So those are some of the things you can do. Some of the tools that you can use are WebDNN, which is what I've talked about. There's also a couple of others, like Keras. There's another one, JS, TensorFire.js. DeepLearn.js is a library released by Google, which allows you to do both training and inference in the browser. So there's many tools that you can explore, and they all have demos and examples to start with that help you get started. So what's best for your needs? So this is probably the most interesting slide for you all. So if you're thinking about implementing some machine learning into your application, what should you be thinking about, and how should you decide whether to put the machine learning on the server or on the client? So these are a couple of the points that you should be thinking about. The first is functionality and model size. So how complex is the model that you want to use? And the browser is only suitable for certain types of models that can actually be optimized. So this is something you need to think about. The second is actually browser compatibility. So as I mentioned, WebGPU is only supported on Safari Technology Preview. So you want to be thinking about what type of browsers are your users going to be using, and is this something that would work for them? The other thing I mentioned was connectivity earlier. So depending on whether your application requires strong network connection. Cost. If $24 a day isn't a big issue for your company or your startup or your app, then maybe you don't necessarily need to use client-side machine learning, and the server is fine for your needs. The last 2 points around source code privacy and data privacy are interesting because source code privacy, if you're running machine learning in the browser, anyone can see your model. Anyone can see your model definition by opening up the developer console. So you want to think about whether that's something you want to keep private. Data privacy is interesting because with client-side machine learning, you're not sending any user data to the server. And if this is something that your users care about, you can tell them that all our machine learning is run on the client, so we don't actually send any of your data to the server. This might be something your users care about. So that was a tour of client-side versus server-side machine learning. I want to end by taking you back to the beginning. So I mentioned this app, this idea, this vision for having the world around you described in the language that you're trying to learn. And this is what really motivated this talk. It's motivated this research into client-side machine learning. And I want to give you a demo of something that I built with a friend that actually enables this to be possible. So this is LingoLens. This is a demo of it working on a phone, so enjoy. I'm Nikhila, Ravi. Send me a tweet or find me after if you have any questions.